Okay, so our third special segment of a triangle that we're going to talk about are called angle bisectors. And they do exactly what you think they would do. They are going to bisect an angle. Okay, so if I know that DF is an angle bisector, then I know that it actually bisects this bigger angle. So, by definition, it is the segment drawn from, let me make sure that I have, so it's a segment drawn from a vertex that bisects that angle and intersects the opposite side of the triangle. Okay, so again, it's drawn from the vertex and it bisects that angle. So if DF is an angle bisector, then angle BDF is going to be congruent to angle FDE. That's all you know. You have no clue where it ends there, other than it's on segment BE. You cannot say that this is a midpoint. You cannot do that. Okay? So let's look at example 1. So we might say that it's an angle bisector, or you might just be given tick marks. Just kind of depends. So we have R, S, T, and V. From the picture, we know that ST is an angle bisector because of the tick marks showing that it creates two congruent angles. I'm going to tell you that angle RST equals 24. So I want you to find the measure of angle TSV and the measure of angle RSV. So if RST, that's this little angle in here, if this is 24 and it's an angle bisector, then that angle is 24. And then the whole angle is 48. So much like with some other things we've done the segment addition, this fits really well with the angle addition postulate. Let's do example 2. Okay, so I'm going to be given the fact that PX is an angle bisector, so that is given. I'm also given that the measure of angle YXP is 4x plus 5, and the measure of angle PXZ is 5x minus 2. I'm going to put that information in my diagram. So if PX is an angle bisector, then I know that that piece is going to be congruent to that piece. YXP, this angle is 4x plus 5. and PXZ, which is this one, is 5x minus 2. If they are congruent, then we can set them equal to each other. So 4x plus 5 equals 5x minus 2. I'm going to subtract 4x on both sides. And I'm going to add 2 to both sides. Oopsie. So I get x to equal 7. Again, check your work. If I plug a 7 in here, 4 times 7 is 28, plus 5, that makes this angle 33. If I plug a 7 in there, 5 times 7 is 35. 35 minus 2 is 33. So it does check. One more example with angle bisectors. Okay, so I know it's an angle bisector. I'm going to label this as angle 1 and angle 2. And I want you to find x, and I want you to find the measure of angle 1. And we know that the measure of angle 1, let's put this in here, is 7x plus 7. And then the whole angle is 16x plus 4. So if this piece is 7x plus 7, then this piece over here is also 7x plus 7. So again, building on that angle addition, this angle plus this angle equals the whole angle of 16x plus 4. So 7x plus 7 plus 7x plus 7 should equal 16x plus 4. I'm going to solve by combining like terms. 14x plus 14 equals 16x plus 4. I'm going to subtract 14x on both sides. I'm going to subtract 4 on both sides. And then finally, I'm going to be divide by 2. I have x to be 5. Measure of angle 1. So if I put a 5 in here, 7 times 5 is 35. 35 plus 7 gives me 42. So I'm going to check it. That's going to be 42, which means the whole thing has to be 84. So let's put that in there. Put a 5 in there. 16 times 5 is 80 plus the 4 gives me 84. So that does check.